this is part 3 of the Cube Destroyer tutorial. Hopefully you have finished parts 1 and 2 and you have your game working up to this point. All that we have done so far is we have this cube's text should just say temporary on it when you hit play. Your win screen should not be here, and every time you hit play, your ground plane should be a different color. So when we just test it one more time, and we see that we have red, and if we click it again, we have yellow. We're actually a decent amount through this lab. We don't have, honestly, that much left to do. We have to generate all of our cubes, do our check for clicks, but if you remember, we did this in our raycasting video, so we can just reuse our code for that. And then we just have to do our print cube count and our check for win to check for a win condition. And ultimately, after this one is done, we'll have to do our cube color script, but that is going to be pretty fast. So the first thing I do want to work on next is our print cube count. This one is pretty easy. All it does is it returns a string that will ultimately end up in here that has how many cubes are on the screen. We might as well get this done now because will be useful when we start generating our cubes so that we can check to make sure that we have how many cubes we have on our screen. So first things first, since it is a return function, what I do like to do with these is I do like to make a variable for returning. So I'm going to make a new string variable called toReturn, and I'm going to set this equal to in my quotes cubes colon and a space, so that actually cubes would make more sense, wouldn't it? Yes. So that down here we can just say toReturn, that's that string, is equal to toReturn plus, and if you remember, we have this, we haven't used it yet, so you might have forgotten that we're going to be using it. We have this class level variable called total cubes, and this is to store how many cubes we have in our level. So we can just then say down here toReturn plus total cubes dot toString, so that we will store, since this is storing all the cubes, we'll just add cubes and then the number of cubes, and then we have to make sure we change the return from temp to our toReturn string variable. And that's all we have to do for this. And it's nice that we have this set up so that when we start generating our cubes and we pop back into the game, this should update correctly so we can see that our cube count actually in the game. So let's go up to our create all cubes function. And if you remember, this is to randomly picks how many total cubes will be in the scene and generates a random spot to place them. And we do have to use a for loop for this, just so we can practice using a for loop. And honestly, using a for loop is a really great way to do this anyway. It's not like we're just using a for loop to use one. Most likely you should be using a for loop to do this in the first place. So I'm going to pull up my flowchart, because I actually did flowchart this as well, just so you can also see how you're supposed to flowchart a for loop, because we haven't encountered this yet, and you might not be aware of how to do that. So this is my create all cubes. We have our start, and remember, we need to pick a random amount of cubes. So we're going to just use our random number generator again, and this should say between 5 and 10, not 5 and 11. I don't believe the lab specifies how many cubes need to go in our lab, but 5 to 10 sounds like a decent amount. You want at least 1, and 10, you don't want like 50, because that would take a long time to get to test this out to get to the next level. So 5 to 10 should be good. And then we're going to use a for loop so that for each iteration of the for loop, we are going to generate a random spot and place a cube. So this is how you actually set up a for loop in a flowchart. So think of this as for int. Actually, you know what? I'm going to change this from x just so it's not confusing, since I'm going to use x later on in this. We'll change this to I. While I is, we start with I, for int I is equal to 0, while I is less than total cubes. And the reason it's less and not less than or equal to is because we are starting at 0. If you started I at 1, this would have to be I is less than or equal to total cubes, just so we get 5 to 10 and not too many. So while I is less than total cubes, use a random number generator again for an integer between -4 and 5 for an x position, random number generator for a z position between -4 and 5. And then, if you remember, we do have a function called generate cube to create one cube, and we send it an x integer and a z integer that will be used for the position of that. So this will just be fed into this generate cube function. Excuse me. And this just loops through while this condition is true. After this condition is true, we follow it this way, and we are actually done with this function. So this is all that's in the function. And this is just how you could do a for loop in a flowchart. So why don't we go and code this now that we have our flowchart. So first things first, we do need a random number between 5 and 10. So, and we actually don't need to create another variable to hold this, because if you remember, we use it down here. We have that variable already. That is our class level variable. That's a private up here. Total cubes. This is supposed to store the maximum, like how many cubes are in our scene. So it makes sense that rather than making a new integer, this random number should just go into total cubes, because that's what's going to end up being the initial total amount of cubes. So we'll say total cubes is equal to random dot range 5, 11. And remember, it has to be 11, but it's going to be any number between 5 and 10. It's just not, it's 5, 6, 7, 8, 9, 10, not 11. But that's just how we have to do it. So we have how many cubes we want to generate. We then need to make our for loop. So we're going to say for int x, oh, I'm sorry, I was going to use I, wasn't I? Int I is equal to 0. I is less than total cubes, because we want to place them until we get to that number. I plus plus. We then need an integer to hold a random x, which we can just use that random.range again. And we'll say -4, 5. And an int called random z, random.range, -4, 5. So we have a random x coordinate and a random z coordinate. We are then going to call our generate cube function. We haven't written this one yet, and we'll actually do this one next. And we want to send to it that random x integer and that random z integer. And that's the whole thing. This just translates into this, and create all cubes is done. So next, why don't we do the generate cube? Because this is actually where we populate a single cube into the game. And after we do this, this will be a good chance to test that we are creating this ourselves. And This one I did kind of do a flowchart for, but it's a really simple flowchart. Oops, let's get back over there. Hold on. It's because it's pretty much just a couple lines of code. In fact, it's only just going to be 2, where we just say that we are instantiating a crazy cube object at position X and Z. That's it. And I actually don't have any other flowchart stuff, so I'm just going to close this for now because we don't really need it anymore. So you've done an instantiate before. You've had to use that in the previous lab to create when you did the while loops to place cubes. So if you remember, when we use an instantiate, we need what we're going to instantiate, the position of it, and we actually need the rotation. But we're not too concerned about the rotation, so we will just put kind of like a pretty much just like a dummy value into there. But we are going to need to put a position, its position. And if you remember, when we use 3D objects, position is done with using a vector3 object because that holds X, Y, and Z. So first we need to just create a vector3. I'm just going to call this vector3 object cube position. And it's going to be equal to a new vector3 object. And we know the X because that's what we're sending to it right here. X. We'll talk about the Y in a second, but we also know the Z because we're sending the Z information to it as well. We don't have any Y because Y in Unity is our up and down, and we're not really dealing with any up and down space. So if you did set up your game board the way it's done in the directions, we can just set Y equal to 0, and that will just drop our cube on the board. If you didn't quite do the size correctly, based on the instructions, this might be slightly different. It might be like a 0.5 or like a 1 or something like that. But if you follow the directions, this is what it should look like. We then are ready to instantiate one version of our crazy cube prefab. Because remember, we did feed that into here. Put this public transform crazy cube. So kind of as review from last week, to instantiate, we write instantiate, and in our parentheses, we tell it what we want to instantiate. Our crazy cube, where we want it to instantiate, at cube position, and at what rotation. And we're not really too concerned about that. So we're actually going to just say quaternion, I think that's how you pronounce that word, dot identity. And that's just kind of like a dummy, like you have to put something in there. That's just kind of like a basic one. And that's all we need to do to generate this cube. So now that we generated it, we can test this out. And you might be asking, you know, it's only 2 lines of code. Why didn't we just put that in there? And this starts to come down to kind of like a style and where you kind of start to get a feel for programming. Generally, the name of a function is what it does, and it shouldn't do any more than it says. So like if you have to make a really long function name, then there's probably going to be too much stuff in there if you can't just describe it in a quick blip of this. So create all cubes. This is just responsible for creating all of the cubes. But what if, you know, this is for the board. What if this game got a little bit more complicated? What if we needed to generate cubes for another reason other than here? Like what if when we click on it, like on a cube, rather than just it disappearing, what if we had like a cube kind of look like it was spitting out like a projectile towards what we clicked on? We could use this generate cube to create an instantiation of another cube that we could use as a projectile. Because we could say like generate cube, and then, you know, if we had like a shoot cube function. We could say generate cube, and then we could apply force to it to shoot it. So functions are great so that you can kind of recycle code and use them in multiple places. And it's just something that you kind of learn to do and get more of like a feel for it the more that you do programming. So that's why in the beginning we kind of tell you what functions to do, but eventually you're going to have to start learning how to break up your code into your own functions, because you don't want a million functions, but if you only have, if you try to just stick this all into 2 functions or just stick all of this code into your start and update, that's not good programming practice. And you're probably going to end up reusing a lot of code that could have been broken down into its own functions. So with that said, we do have our cubes should be generating now. So let's pop back over to here and let's hit, did I save it? Let me just double check. Nope, I did not save it. I still have the little star next to the name. So let me save this, come back here, and let's click play. And it says I have 10 cubes. And so this is working. Let's make sure we do have 10 cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we do. If my cubes act a little bit differently, because I think I put actually put physics on mine. I put a rigid body. You don't need to do this if you don't want to. And I think mine appears slightly above the ground, so they kind of fall, which you can do if you want, but it's not part of the lab. It can make it a little bit more fun though. So we had 10 and a magenta board. Let's hit play. We have to make sure the randomness is working. So we have 6 this time. 1, 2, 3, 4, 5, 6, and they are in different positions, and it's on a yellow board. Green board this time, 7 cubes. 1, 2, 3, 4, 5, 6, 7. So this does appear to be working. If you are curious at what my camera settings are, because you want this to be in the same position, my ground is at the origin. My camera settings though, my position, my X is 0, my Y is 5.57, my Z is -7.2. My rotation is 45 degrees on the X, and the rest are 0, and there's no scale on this. So this will give you the same perspective if you kind of like the perspective that I'm using with this for that. So we're doing really good. We have everything is generating. We actually have everything done here. Like the start is done. We just have to work on our update now, the check for clicks and our check for win. And we have this done because you should have done that raycasting video before this. And I'm actually just going to open up, because if you're in Visual Studio, you can go to, if you can just, oops, not that. You can just open a file and you can locate your, you can locate the code for your last one, and I did the wrong thing. I called it the wrong thing. That's okay. Here's my game controller script from the raycasting one, and I called it exactly the same thing, check for clicks, where we did checking for a mouse button and we did all of our raycasting. So I'm actually going to just copy paste this. It's not going to be perfect, but it's a lot better than typing this all in again. So I'm just going to highlight from this curly brace to its end curly brace. Control C to copy this. Go to my current game controller, check for clicks, highlight these, and paste this in. And I do want to double check that I'm not getting any kind of weird errors, like I didn't mess up a curly brace somewhere, and it looks pretty good. So I can now just close this. And let me zoom back in so you can see this a little bit better. And it's not perfect because there are things that I do have to change. The left mouse button is correct, And we are declaring this correct because it's still from the main camera to our mouse position. And remember, you do have to make sure that our main camera is tagged as main camera. And this is fine. For this, this is still okay. And 100 units should be still a decent space for raycasting to work. This, though, is incorrect. I actually, in this one, I didn't name it capital C cube. I used a lowercase c for cube. So you do want to double check that your tag is correct. And we are destroying this object, so that is correct here too. So we only had to make a little bit of a change. Sometimes you might have to make more of a change, but you know, why retype code that we've already got working? That doesn't make any sense to me. So we're just going to recycle this. So honestly, this should work. So now that we got our tags set correctly, we should be able to destroy our cubes. So let's save this. Go back to our game and let's try it out. So we'll hit play. And let's double check. We got it. It's red. That is kind of random. We have 9 cubes. 9 is between 5 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is still functioning correct. It's always good to double check because you want to make sure that we didn't break anything too. So let's click. Yep, our cube is destroyed. You can also see that it popped out of our hierarchy. If we click on the ground plane, it's not destroyed and nothing else gets destroyed. If we click off into the sky, nothing else happens. So we can click here and all our cubes are destroyed. But notice our number isn't changing. We haven't dealt with that yet. And if we destroy all our cubes, we still don't get our win screen. So we haven't dealt with, we got to make sure that we are updating our cube count and we have to get our win screen done with that. So the easiest thing to do would be to deal with changing that cube count right after we destroy it, because we want to make sure that nothing else gets in the way of that, because that's something that's really important. And the first thing we'll have to do is when we destroy a cube, we have to make sure that our total cubes reflects that. So the easiest way to do that, and this is why this is a class level variable, so we can just access it here, is just say total cubes minus minus. So it's going to decrement our cube count, but we still need to change our text on the screen. So we're going to call that count text again. And actually, you know what we could do? We could come up here. Like I said, I don't like to type things more than once if I can help it. This does that. So we can just highlight this because we know this works. Highlight this, copy this, and just paste this in where we need it again. We'll just paste that in. And so now it should be updating. I know we didn't code too much more, but this would be a good time to test again to make sure that what we didn't break anything, and that it is working correctly. So 7 cubes, and that's correct. 6 cubes, 5, 4, 3, 2, 1, 0 cubes. And if we click on our plane, it doesn't change that, so it is still not registering that this is nothing. So we know that we are still getting a good, it's still working correctly. We didn't break anything. All right, so the last thing we need to do in our game controller script is this check for win, which gets called right after we check for clicks. So we're going to check for win after we check for clicks, because if we are clicking on the last cube, we want to make sure that we won. And this is really easy, and this, you should kind of know how to do this already. We're just going to check for a win condition, and we know we've won when total cubes is equal to 0, because we don't have any cubes left. So this is just going to be an if statement. So we're going to say if total cubes is equal to 0. And remember, it is the double equal sign. If we do this, what's going to happen is total cubes is going to be set to 0 whenever this is called. So we'll get our win condition right away. It'll automatically set that equal to 0, and it'll tell us that we won. So make sure you are doing the double equal sign. So when is equal to 0, what do we need to do? We need to show that win panel so that our win text becomes active and our next level button becomes active. And we have already kind of used that code before. So if you remember, we did that in the start. So come up to the start, find it again. We're gonna, because we know that this works, highlight it, copy it. We're gonna go back down to here and paste it in. The only difference is we want to set active to true because we want to see the panel now. So now when we win, when total cubes is 0, we'll be able to see our win panel, which means that we'll then be able to click our next button, which reloads the, well, it loads the scene again. It doesn't, I guess it technically does reload the scene, but if we had multiple scenes, it would go to the next one. So let's save and test this out. So we'll hit play. We have 6 cubes. 1, 2, 3, 4, 5, 6. And our win panel comes up. Next board, I don't think we've been able to test this yet, so let's click it and let's see. So we should get a random color and another random amount of cubes placed randomly. And that did happen, so let's click it. And there we go. And now we can just sit here and play forever. So the last thing we have to do is we have to actually do our cube color one. And the cube color script is on top of the Crazy Cube prefab, and this just randomly picks a color for that. And I'm going to stop the video here and we'll do that in part 4. Make sure that you have this game working like this up to this point, and then we watch the next one, and after that this lab will be done.